Okay, so welcome to Mathstoria and let's have this problem. So this one is a proving trigonometric identities. So in proving trigonometric identities, we need to rewrite first all the functions in terms of sine or cosine. So therefore, this cotangent is equal to cosine x over sine x plus this cosecant x, so that's 1 over sine x, then over the sine x, so since this one is already sine x, so just bring down, then minus, again, cotangent x is equal to cosine x over sine x, then minus this cosecant is 1 over sine x, then we have plus. So this second is 1 over cosine x, then equals 0. Since all the functions now are sine and cosine, so we're going to perform the given operations. So for this equation, since the same denominator, so just copy. So we have sine x, then for the numerator, so just add cosine x plus 1. So this one is cosine x plus 1. Then all over, so just bring down this sine x. Then minus, since the same denominator, so just copy. That's sine x. Then add or subtract the numerator. That's cosine x minus 1. Then plus this 1 over cosine x, then equals 0. Then we can simplify this equation. So copy first the numerator, that's cosine x plus 1 over sine x, then all over. So for this equation, so we can find the LCD, and that's sine x. Then this one is over 1. So sine x divided by 1, that's sine x, and sine x times sine x, that's sine squared x. So sine squared x. Then minus, so sine x divided by sine x, that's 1 times cosine x minus 1. So copy cosine x, then minus 1. Then we have plus 1 over cosine x, then equals 0. Then take the reciprocal of this equation. So we have cosine x plus 1 over sine x, then times the reciprocal. So that's sine x, then over this sine squared x minus cosine x minus 1, then plus this 1 over cosine x equals 0. Then we can cancel now this sine x. So we have now cosine x plus 1 over this sine squared x minus cosine x minus 1 plus 1 over cosine x equals 0. Then simplify. So from this cosine x plus 1 over, so we have sine squared x minus cosine x. So that's sine squared x minus cosine x minus. So we're going to rewrite this one in terms of sine and cosine. Since sine squared x plus cosine squared x is equal to 1, so we're going to substitute this equation to 1. So that's become sine squared x plus cosine squared x, then plus this 1 over cosine x equals 0. So we have 1 over cosine x then equals 0. Then simplify, so we have cosine x plus 1, then over this sine squared x minus cosine x, then distribute this negative, so that becomes negative sine squared x, then distribute, so negative cosine squared x, then plus 1 over cosine x, then equals 0. Then this sine squared x and negative sine squared x, this one is 0. So we have now cosine x plus 1, then over. So we need to arrange this equation to start with the highest exponent. So that's negative cosine squared x, then minus cosine x, then plus 1 over cosine x, then equals 0. Then for this denominator, we can factor out negative cosine x. So we have now cosine x plus 1 over. So if we're going to put this negative cosine x outside, so this negative cosine squared x becomes cosine x, because negative cosine squared x divided by this negative cosine x, so cancel negative, cancel 1, so that's cosine x, so that's why that becomes cosine x. Then this negative cosine x divided by negative cosine x, so negative divided by negative, so that's positive 1. Again, negative cosine x divided by negative cosine x, so a number divided by itself is always equal to 1. Then plus 1 over cosine x, and that's equal to 0. Then we can cancel now this cosine x plus 1 and cosine x plus 1. So we have now this 1 over this negative cosine x plus 1 over cosine x, and that's equal to 0. So this 1 over negative cosine x plus 1 over cosine x. So if we have negative 2 plus 2, the answer is 0. If we have negative 1/2 plus 1/2, the answer is 0. So therefore, this 1 over negative cosine x plus 1 over cosine x, that's equal to 0. And 0 is equal to 0. So therefore, proof complete.